So here are some explanations on how you can help learn some new memorized integrals. You already know the first two because the integral of sine is undoing the derivative that gives you sine, which is cosine. Only the derivative of cosine is negative sine, so that's a negative. And the derivative of sine is cosine, so that's just straight sine. So you already knew those based on what you knew about derivatives. Some new ones, let's skip down to the bottom here. Secant of u. There's a proof in the book if you want to see how to do it. The way you can remember this, these all have natural logs. The derivative of secant is secant tangent. The integral, though, is secant u plus tangent u. So very similar looking. There's just a plus instead of a multiplication. Same with cosecant. The derivative of cosecant is negative cosecant cotangent. The integral of that is negative natural log cosecant plus cotangent. Very similar to the derivative. Tangent could be written as sine over cosine. And we want u prime over u. Well, that's really close to being u prime. U prime would be positive sine. That's not a positive sign, it's a negative sign. So negative natural log of cosine. Because the u is always the denominator. Cotangent could be written as cosine over sine. U prime over u, that means our u is sine and the derivative here doesn't change. Probably the two hardest ones to remember are the middle ones because they don't have a connection. I wouldn't memorize them. I would think about the fact that you can rewrite and memorize. We're talking about the natural log. So those are your new properties. So we know that this is a u substitution problem because there's a derivative that's not equal to 1. And we know what the integral of tangent is now, so all we got to do is get that into a u form. So u is 5 theta, du is 5 d theta. Let's go ahead and stick with the theta. If you don't want to change, if you want, you could change everything to x. D theta equals du over 5. So we rewrite it. So we have the tangent of u. D theta is du over 5. So that's 1/5 integral of tangent of u du. We just said the integral of tangent. Tangent is sine over cosine, and I would memorize it like this. Memorize it, you have to rewrite it. So that's u prime over u, with the exception of the u prime should have a negative. So final answer, negative 1/5 tangent 5 theta plus c. Sorry, natural log of tangent 5 theta plus c. Go back to looking at tangent. Tangent, I think I wrote the wrong one. Late night video making. Your u is right there. So negative 1/5 natural log cosine of u plus c. And your u is 5 theta. Get it back in the right form. Alright, let's see if I can do this without screwing up. Let u equal the x over 2. So du is 1/2 dx. So dx equals 2 du. That's all for dx. Substitute secant of u, and then dx is 2 du. So we have 2 secant u du. A new derivative rule, integral rule. The derivative of secant is secant tangent. The integral of secant is natural log of secant plus tangent. And then the u value just gets substituted. You always want to end up with the same angle that you started with. And if you took the derivative of this and combined everything, you'd end up back here. We're not going to go ahead and verify that. Okay, next integral. Use your rules of integrals to break it into two integrals. So the integral of 2 is 2x. And then the integral of tangent of theta over 4. Let's do a little side substitution. You can break up sums and differences. Let u equal your angle. So du equals 1/4 d theta. D theta equals 4 du. Substitute. So we have tangent of u times 4 du. That's our d theta. So 4 integral tangent of u du. Tangent is sine over cosine. Means we have a negative natural log because the derivative of cosine is negative sine. So when you put it all together, you have negative 4 natural log cosine theta over 4 plus c. Those are just some different trig examples. If you get to one that you don't know how to simplify, like 38, doesn't really follow our rules. So we have cosecant squared over cotangent. When in doubt, let the denominator be your u value and see if something works out. So if you let u equal cotangent, then du equals negative cosecant squared. So dt equals du over negative cosecant squared. Substitute. We have cosecant squared over u, and then dt is du negative cosecant squared. Cosecants cancel out. Now we have what we want. 1 over u du. Put the negative out front. So negative natural log cotangent t plus c. So this one was not using one of our memorized rules. When you get it down to here, you're still taking the integral. And if it's not one of those trig functions, you're just doing the regular old integral.